Good evening, everybody. Welcome to tonight's Shooter to Eurovision Blast. I'm Laura, and I'm joined by Laura and Melissa. Some familiar faces for you tonight. Tonight we're focusing on all those pesky biological bits, so jumping from nervous systems to neurons to other bits and bobs that you'll see across your specification. So, as always, answers in the chat. It's an interactive session. I've seen some of you ask already if you can ask questions throughout the session, and you absolutely can. Melissa and Laura will endeavour to answer anything that we see pop up. So, without much ado, let's take it away, Melissa. We're starting with you.
Yep, we are tonight. We're going to go first activity. Okay, so as Laura said, we're looking at some of our more trickier biological bits tonight. But just to get us started, I want you to have a go at seeing, can you fill in the blanks of this nervous system? So we've got some gaps here, A, B, and C. What do we think's missing? And just pop your answers in the chat box for me when you think you know. Just make it clear as well which one you are going for. So A is what, B is what, and C is what. Okay, we've got a lot of A's coming through saying spinal cords. That looks good. What about B and C? Okay, yeah, a few coming through now saying the somatic nervous system. Got quite a few of you saying that one. Well done. Some fabulous answers there. And really quick as well, guys. Well done. Let's have a little look at the answers. And I think for all of you who gave it a go, you were completely correct. So this is just something to be aware of in the exam. You might be asked to label the nervous system diagram. You also will need to know about each of these different parts of the nervous system and what they do. But this is something we're going to pick up on a little bit throughout the rest of this session. So without further ado, next activity. And we're over to Laura.
Okay, guys, so our true or false game. So let's read. The somatic nervous system is responsible for the body trying to conserve energy. Do we think that's true or false? And it's always tends to be an area, somatic nervous system, that students never quite know what it does. So let's see what we've got. So KF, I think you got in there first with false, then TF, K, and then Jenna. So there are some mixtures. Some of you have said true. So the answer here is false. Now, can anybody tell me what system is responsible for the body trying to conserve energy in the nervous system? What might that be? Yeah, EBS, well done. Parasympathetic, excellent. Yeah, really well done. So that's kind of the idea of bringing our body back down to relaxation, equilibrium. Yeah, I can see a lot of you have said parasympathetic there. Well done. All right, let's look at the next one then. So we've got the PNS has two main aspects, a motor and a sensory system. Is this true or false? Okay, so wow, they came in really, really quick there. Yeah, so a lot of us are saying, I think the majority of us are saying true, but we do have a couple of falses in there. So let's reveal the answer. So this particular answer is true. Now, can anybody tell me, we looked at the diagram a moment ago of the nervous system, which aspect is the motor part of the PNS and which aspect is the sensory part of the PNS? Can anybody tell me the difference there? Which one's which? So you've got to think back to that diagram. What was the divisions? Yeah. Yeah, so we've got somatic. A couple of you are saying yes. Okay, all of the answers are coming at once here. So we should have the motor, if you like, as the autonomic, which I think a lot of you have said, and then obviously sensory is just somatic from what I've read there. Excellent, well done. Let's have a look at the next question then. So for this one, we've got the endocrine system is a faster system in comparison to the nervous system. So I often depict endocrine and nervous system as either a WhatsApp message or an email, which is a really good way to remember the difference in terms of the system. Yes, yeah, a few of us are saying false there. A couple of you are saying false. So yeah, the answer for this one is false. And again, endocrine system is a bit like sending an email. It's going through our bloodstream, so it's a bit slower. The nervous system tends to be electrical impulses, and that's where our synaptic transmission comes in. So it's a lot quicker, the nervous system. So that one is false. Yeah, well done. Yeah. Let's have a look at the next one then. So in synaptic transmission, neurotransmitters diffuse from a low to a high concentration or gradient. Is this true or false? Yeah, excellent. Quite a lot of us think we've got a unanimous false there. Can anybody explain what it should be reading then? Or a bit of an explanation behind that? Again, this is going to come into obviously our synaptic transmission. We're going to cover in a bit more detail in today's session in case anybody's not feeling too confident on that. Yeah, great. So it goes from a high to a low. Well done, all of you. Excellent. All right, so the next one is inhibitory postsynaptic potentials decrease the likelihood of postsynaptic neurons firing. Is this true or false? And again, inhibitory postsynaptic potentials, excitatory postsynaptic potentials, you are going to need to know because that comes into synaptic transmission. Okay, so Cara, I think you got in there first with true. I think pretty much all of us are saying true there. Yeah, so inhibitory, it says it in the name, doesn't it? So we're inhibiting the communication from continuing there in the postsynaptic neuron. It's not going to fire, or it's a less likelihood of it firing, if you like. Excellent. Going to pass you over to Mel for Give Me Three.
Okay, so we're going to have a little look at 3 types of neurons for this activity. So there's 3 types of neurons that are listed on your specification. Simply, I just want you to tell me, what are they? So what are your 3 types of neurons in the box? Okay, well done. Some of you were so fast with that. I think you managed to get your answers in before we'd even started the timer. So well done. Excellent. Yeah, if you've said relay, motor, and sensory, you would be correct with those 3 different types of neurons. So we'll see them on the screen now. So you've got your motor neurons, your sensory, and your relay neurons. Okay, sticking with this now then, let's have a little look if we are able to identify the neurons from these pictures. So what do we think? So we've got A, B, and C here. One is a relay, one is a motor, and one is a sensory, but which one is which? I'm laughing at some of the comments about the music, feeling like you're on a Spanish holiday. I'm glad you enjoyed it. Okay, oh, we don't know who was first on that one. They all came through in one go. Let me have a look and see. Poppy Mesney there saying A is sensory, B is relay, C is motor. Okay, question for you then. How do we know? How are you so quick at getting those? Can you give me any identifying features of these neurons? It's something we've got to know in the exam. We've got to be able to identify each of them. But why? What distinguishes each from each? So let's pop some ideas into the comment box if you've got some. How do we know which one is which? Okay, I can see no cell body on the relay. Okay, can you be more specific what we mean by cell body? Okay, so we've got cell body in the middle, sensory. Long dendrites, which one are we referring to there? Let's have a little look. Motor goes to muscle or tissue. The relay's got a long, thin axon. There's lots of good ideas coming through here. Well done. Keep them going if you think you've got some more. So the motor neurons, axons connect to muscles, sensory dendrites connect to tissue. All right, let's have a little look at some of the ones we've come up with. See what we can see. And I think for some of these, I think from reading the box, you guys have mentioned some, if not all of them. So let's start with the relay, which is the one in the middle. Now, I haven't seen this, but it doesn't mean nobody said it. So relay's got no myelin sheath. So myelin sheath is sort of like that bubble coat that protects the axon that goes around it. And if you look at the middle one, we can see that it doesn't have that protector around it, right? So the myelin sheath is there to sort of speed up the action potential that goes down the axon, and those nodes of rambia is what is going to carry it a little bit further and a bit quicker. With the relay, it doesn't have that on it, so that's one way we can distinguish it. We could also say that the motor has got a larger cell body. You can see that on the right one. The motor's also got longer dendrites in comparison to the others. I've seen one that I teach a lot of my students, the idea that with the sensory neuron, the cell body sits outside, or yeah, it's sticking out. So that's a good way to remember it. Sensory begins with S, and so does the word sits. So it sits outside it. Lovely. Okay, let's move on then to our next one. And this is over to Lara.
Okay, so I read Herring Game, guys. Which of the 4 items is the odd one out? And the most important thing here is, why is it the odd one out? So this one's quite a hard one to start with. So we've got dendrite, cell body, axon, synaptic gap. So there is an odd one out there. And again, when you give me your odd one out, tell me why you think it's the odd one out as well, if you can. So again, this kind of goes hand in hand with what you've just spoken about with Mel. Yeah, so Jolie, I think you just got in there by saying, God, where's your answer gone? The answers are coming through so quick. Yes,
No,
so
it's so fast, aren't they?
Synaptic gap is the odd one out because, as some of you have quietly realised, A, B, and C are part of the neuron, and synaptic gap is not. So really well done. Again, we're going to look at that in a bit more detail with synaptic transmission in a bit. All right, let's look at number 2 then. So number 2, we've got IPSP, EPSP. If you don't know what that stands for, it's inhibitory postsynaptic potential and excitatory postsynaptic potential. We've got summation, we've got receptor sites, and then we've got vesicles. So again, which one's the odd one out, and maybe what do the others have in common? Or okay, so yep, we're saying vesicle, Sakara. I think Grace, then you followed, you got in there with D. Can anybody tell me why it's D? Yes, a couple of you have saying summation. Yeah, you're on the right lines, guys. So think about what are the 2 neuron names we have and what happens at each neuron in synaptic transmission. Oh, this is quite a hard one. I can see we've got some good answers coming through. It's maybe not quite the one. Okay, so can anybody tell me what are the two neurons we've got in synaptic transmission? We've got, what are they called? Yeah, pre and post synaptic. Well done. So there's something that A, B, and C have that are all in common to do with the neurons. Can anybody spot what that might be? Yeah, so Layla, well done. So D, the one you've picked out, which is odd, happens in the presynaptic neuron, right? Whereas receptor sites, summation, IPSP, PSP happens in the postsynaptic. So postsynaptic neuron features in synaptic transmission for this one. Well done. Okay, our next one is we've got the gonads, pituitary, adrenal, and the hypothalamus. So again, what's the odd one out, and what do the others have in common?
Quite a few people are asking what summation is in the chat.
Yeah, we're going to go through summation when we cover synaptic transmission. So summation is basically, let's say, for argument's sake, on the postsynaptic membrane, you have, I don't know, 5, let's just keep it simple, 5 excitatory postsynaptic neurotransmitters and 2 inhibitory. The sum of all of those, if you look at that in a ratio, the likelihood of there being an EPSP is higher because there's more postsynaptic receptor sites being activated by excitatory neurons rather than inhibitory. So that's what we're talking about when we talk about summation. Okay, so a lot of us, I think, are saying A for this one. It's not A. It's actually the hypothalamus. I don't know if anyone put hypothalamus. I can't see that anyone did. So the thing that A, B, and C actually have in common is they are actually all endocrine glands. Okay, and again, you don't, in the specification, it doesn't specify which glands you need to know, but I would know, the major kind of glands, if you like, or at least four glands, and kind of what their output is in terms of hormone, and then what effect that hormone has on our body as well. Okay, I'm going to pass you over to Mel now for Crack the Code.
Okay, so as Laura just said, we're going to have a little focus on synaptic transmission for this activity. It is quite a difficult one. This is an area of the spec that a lot of people struggle with, particularly writing about it and getting it in the correct order. So that's what we're going to ask you to do here. So what you've got in front of you, or you should be able to see on the screen, are lots of different parts of synaptic transmission. And all we want you to do is spend a little bit of time putting this in the correct order, from what happens first to what happens last in the process. And then we'll have a little chat through it. So have a little think. What do we think it goes in the correct order here? What are we going to start with? Okay, so Summer, you've got your answer in first. You are nearly there on the right lines, not too far off. Same with Layla, also very nearly there. Trying to see if anyone's got it correct in the correct order. Oh, they're coming through so fast.
I think Rach Armstrong's got the correct one there on the chat.
Yes, well done, Rach. I think you have got the correct one there. I think that's the first one from what I can see. And is it what you can see as well, Laura? The first one I can see that looks correct. So well done, Rach. Let's have a little look then at the order they should have gone in. So apologies if we missed you. The chat is going so fast tonight. There's so many of you online, which is really good to see. But it should go E, C, A, D, B, and F. So well done if you got it in this order. I'll just go through it very quickly for you. So essentially what we're talking about first is the idea that that action potential, that electrical signal, is going to fly down the axon and it arrives at the presynaptic neuron. Now remember, with presynaptic, we just mean before the synaptic gap. So this is the neuron before the gap. Now what happens here? Well, with that action potential, it causes those vesicles that encompass the neurotransmitters, so that surround them, that sort of hold on to them, to merge with the membrane. After this, the neurotransmitters are going to purge into the synapse, into the gap, and they sort of work on this lock and key way. Now, a few people get confused by what that actually means. It just means that certain neurotransmitters are going to fit certain receptors on the postsynaptic neuron. So they're going to fit as lock and key with their respective receptor sites on the postsynaptic membrane. Then the neurotransmitters, Laura's given us a brief introduction to this before and a very good one, either have an excitatory or inhibitory effect. So what this basically means, if you haven't heard of these terms, excitatory, inhibitory, or summation, it is something you're going to want to have another little look at. If your reaction is excitatory, it's going to make the action potential more likely to fire, and if it's inhibitory, then it's less likely to, and you can see that there at the end of D. How do we work that out? Before, Laura said about the summation, so we basically just add it up. If you're struggling with this, think about maths. We work out the sum. If we've got more excitatory, then it's more likely to fire, and if we've got more inhibitory that reach and cross the synaptic gap, then it's less likely to fire. Then what happens? So once the neurotransmitters have had their desired effect, they're going to unlock from the receptor sites, and they either diffuse into the synapse, get absorbed by enzymes, or they go through a process of reuptake through the presynaptic neuron. This can be quite difficult actually as a question, and I think generally what we see is most people stopping at about A here. So they say about the action potential, firing down the presynaptic neuron, hitting those synaptic vesicles, and the idea that the vesicles will cross the gap and connect to the receptors on the postsynaptic neuron. And then a lot of people stop there. So it's just worth bearing in mind how much extra detail you are able to give if this question comes up. And maybe there's something on the screen here that you didn't actually know about, and it might be something you want to write down so that you can go and have a little look at it and take it away this topic. All right, okay, so let's have a little look what we've got next. We're going to pop over to question focus, and I'm going to shift you back over to Laura for this one.
Great, thanks, Mel. So let's have a look. We're just going to concentrate on some exam skills here. So what do you need to spot in this question? So I want, phrases or words in this question. What is it telling you to do? What are the important command words? What are the important key aspects of this question? I'm looking at this and I can definitely highlight 4. So example, outline, definitely endocrine system. Yep. Anything else? I think we've got function in there as well. So spot on. I think between us all, we've got all of the key words. So if we have a look, definitely. Obviously, we're outlining the function of the endocrine system in the human body, but we've got to do so by using an example to illustrate that and really showing that demonstration and depth to the examiner by giving that example as well. And that'll really help and aid to get those 4 marks. Okay, let's have a look at an answer for this one because students often struggle with the endocrine system. So we've got the endocrine system is a network of endocrine glands of which the pituitary is the main controlling gland. The main function of the endocrine system is to regulate physiological processes through the release of hormones. The endocrine system manufactures and secretes a range of different hormones that travel via the bloodstream to receptor sites in different parts of the body. For example, the adrenal glands. The adrenal cortex produces cortisol in response to stress, and the adrenal medulla releases adrenaline and noradrenaline, which prepares the body for fight or flight. So again, we started there with that outline of the function. And remember, function is very similar to the role of. So we're not just outlining this is the endocrine system, it's what its function, what its job is. And then we're using an example there as it's asked us in the question to demonstrate that in a deeper way. Okay, I'm going to pass you over to Mel for categorise next.
Lovely. Okay, so quite a straightforward one, hopefully a straightforward one for you. You're going to have a 60-second timer to separate the key phrases that you can see on the right into whether they belong in the nervous system or they're a feature of the nervous system, or whether it's more to do with the endocrine system. Now, you guys are so fast tonight, so we're going to get this timer started straight away. Okay, so again, apologies if I'm wrong. It's so difficult trying to keep up with this chat tonight because you're all on fire. It looked like Layla and Ellie were some of the first ones to give us some of the correct answers that came through, but let's have a little look what we've got available here. Okay, so a lot of you went for a bit of an even split. That was one thing I noticed. A lot of people were saying that there were 4 that were correct for the nervous system and 4 that were for the endocrine system. And a lot of you, I think, were missing number 6 for the nervous system. So let's have a little look through them. So we've got 3 was for the nervous system, that it acts rapidly. We spoke about that one before. Whereas the endocrine system acts a lot more slowly. So your glands and hormones tend to work a lot slower than the nervous system does. And I like that idea before, Laura. I'd not heard of that about the WhatsApp versus email, so that's great. Nervous system, we've also got the idea that it consists of your nerve cells that communicate towards the brain and away from the brain, and it acts by transmitting nerve impulses. It has direct control, so it works directly in this way, and specific localized effects of neurotransmitters are going to work more for the nervous system. Whereas the endocrine system, as we've said, it does act slow. It consists of these ductless glands that we often refer to them as, and it acts by releasing those hormones and essentially making those parts of the body work in the way that they need to work. Okay, so I think that takes us nice time onto one of our last activities. Is that right?
Yep.
Yes.
So
lovely.
this is the
Thanks.
missing labels, which, although we're applying, synaptic transmission to OCD here, if anybody does want any questions answered just for the last few bits of this session tonight on synaptic transmission specifically, then feel free to pop your answer in the chat box. But this activity that you're going to do now is label 1, 2, and 3 in this diagram. Okay, so make it clear with your answer which one is 1, which one's 2, and which one's 3. All right, your time starts now, guys. Okay, really good answers coming through. I think JT Galaxy, you've got the first one right and the second one right. But I think the person that's got all of them right to start was Natasha. So well done, Natasha. So if we go through the diagram, hopefully some of you have recognised that kind of purpley blue big dot there, which is blocking the reuptake of those red neurotransmitters, is an SSRI. Because remember, we're doing this with regards to OCD, yeah? And then we've got our vesicles, which is basically these sacs, if you like, which hold a bunch of neurotransmitters, and they bind with the presynaptic membrane and kind of empty them or purge them into number 3, which is the synapse. It's good to see a lot of you got that one correct. Obviously, then the neurotransmitters usually go and bind with their respective receptor sites on the postsynaptic nerve. Once they've had their desired effects, they pop out. And they either get reuptaken, which is the process that we know for OCD. And what happens is we don't have enough serotonin. So these SSRIs come into play. They block the reuptake, which allows that serotonin neurotransmitter to keep impacting for a longer time on the postsynaptic membrane on those receptor sites. So if anybody does have a question they want answered, I don't think so. I think we've pretty much got that. There's really good answers coming through, guys, tonight.
Yeah, great answers. One that has popped up a few times. I think some people are worrying that this could be a 16 marker. And to be fair, it's not out of question to get a fight or flight 16 marker. But with regards to the transmissions, the nervous system, all that whole business with the summation, etc., that's not going to be a 16 marker. But it does come up in quite a few areas of the specification, doesn't it? So where would you
see a few people have said they didn't think it was psychopathology tonight on that last one, but it's just going back to that idea that if you can't do synaptic transmission, you're really going to struggle with how those SSRIs work. So it is linked to biopsych in that way, isn't it?
Yeah, and one of the hardest things about it is your specialist terms, but all we can say is that it just takes a lot of practice. You can watch this back as many times as you like on our YouTube channel. You can keep up to date with us on Instagram at Tutor to Your Psych for some revision tips. We do post daily several times, things that'll help you across your course, but as we get closer to the exam, you'll see us a lot more on there, and we can answer any of your revision questions when you get a bit stuck as well. We're back next week looking at psychopathology, but what we've also got coming up is some exam clinics where you can just come on for an hour and just talk to us, tell us your questions, tell us your problem areas, and we'll go through them and answer literally everything, because that's all we want to do is give you guys lots of support. And finally, I've seen some people panicking that they haven't finished the specification yet. It's, it's only April. You've got a good while to your exams. Some people will finish their spec early, some won't. I think a fair few haven't, and it's just because you're learning the skills properly, so don't worry about that at all. So good luck with your revision. Go through over this tonight, and thank you, Laura and Melissa, for all your help and all your great top tips tonight, and we'll see you next week.
Thank you. Bye.